So this is the 6.2 video answer key for the homework. Again, first thing, I said it on Zoom. I have it written on your notes, on the video notes, and on the homework. Do not do 49 through 66. That is going to drive you up a wall. It's going to drive you crazy. There's a lot of work there. I realized after I wrote the slide and kind of took a closer look and thought about it more that it's just too much for you guys today, especially given how I'm going to give you some more time to practice some of these major skills on Wednesday. So do not do 49 through 66. I've said it now multiple times for you. I have it written in multiple places. So do not blame me if you do 44 through 66. All right. So first, before I even get into this, find all 6 values of the unit circle based on the point. So that's what this is going to apply to questions 11, 13, and 15. I'm not going to do question 15. I'll do question 11 and 13 for you. So find all 6 values based on this point. I'm actually going to go here. I'm going to cheat a little bit, and this is acceptable because if you can make this, if you can recognize this, this is going to help you. I'm going to notice that this is my x and y value, and an xy of root 3 over 2, 1/2, well, this is the exact same thing as pi over 6. In fact, if I go and look at my unit circle, which I have copied and pasted over here for my own reference, oh, would you look at that? Root 3 over 2, 1/2, so that's pi over 6. So as opposed to doing a ton of work, I'm just going to look at my pi over 6, which is right here. And I'm going to go ahead and plug in all my values. So my sine is 1/2. My cosine is root 3 over 2. My tangent, let's go find that one out. My tangent, according to this, is root 3 over 3. Just like that chart tells me, my cosecant is 2. That chart tells me that my secant is 2 times the square root of 3 over 3. And that chart also tells me that my cotangent is the square root of 3. And again, we can go look back at that chart if you don't trust me, and we can see, oh, my sine is 1/2. My cosine's root 3 over 2. My tangent's root 3 over 3. My cosecant is 2. My secant is 2 root 3 over 3. And then my cotangent's root 3. So there you have it. That one was pretty simple. And 15 is going to be a lot like that too. I guarantee you if you take a look at the points on 15 and find your unit circle, you'll be able to go through and figure it out, and you'll be able to plug in your signs. I trust you. I have faith in you. All right, number 13 is a little bit more difficult. This is something that you're going to have to kind of reference on your notes. I don't have my reference sheet right here for this. I copied over a few reference sheets from the last notes, but this is actually going to apply much more. I would check the 6.2 part 2 video notes for some more information on what I'm doing here. Now, what I'm going to be able to do here, and this relates a lot to that Desmos activity that you did, is I'm going to be able to go through, and what I'm talking about here is the fact that my sine is equal to my y, my cosine is equal to my x, my tangent is equal to my y over x, my cosecant is equal to my 1 over my y, my secant is equal to my 1 over my x, and then my cotangent is equal to my x over my y. And again, I've got an xy coordinate point here. So now it's just a matter of putting those where they go. So in this case, I know that my sine is going to be root 21 over 5. My cosine is going to be negative 2 over 5. And those are the easy ones. From here, it's going to take a little bit of, not tough math, but just some tedious arithmetic here. I'm going to be able to say that my tangent is equal to y over x. So in this case, it's going to be the square root of 21 over 5 divided by negative 2 over 5. Well, this is the same thing as the square root of 21 over 5 times 5 over negative 2. These reduce, so then I'm left with negative root 21 over 2. So that would be my tangent. So that'll be my answer for tangent. I already have my sine and my cosine. My cosecant is going to end up being 1 over y. So this is going to be 1 over 1 divided by the square root of 21 over 5, which is going to be 1 over 1 times 5 over the square root of 21. I'm going to have to rationalize this because since this is just 1 over 1, that's going to multiply out to be 5 over the square root of 21. So I'll just kind of get rid of that. So I'll now say, all right, so that's equal to 5 over the square root of 21. I'll rationalize by multiplying by the square root of 21 over the square root of 21. And I'll get 5 times the square root of 21 over 21. And that will be my cosecant value. Okay, I'm going to shrink everything that I've done here, so that way I can make some space. For my secant value, it is 1 over x. So for secant, I'm going to say that that's going to be 1 over 1 divided by negative 2 over 5, which is going to be equal to 1 over 1 times 5 over negative 2. So this is just going to be equal to negative 5 over 2. And then let me change the color of that secant so that way they all match up. Make that green. And then finally, last thing that I'm going to have here, let's shrink that down just to make room here. I apologize for not spacing that one out super well. Finally, last thing that I'll have is my cotangent. So for cotangent, my cotangent is going to be that negative 5 over 2. It's going to be divided by root of 21 over 5. Or this is negative 2 over 5, I apologize. So this is going to be the same thing as negative 2 over 5 times 5 over the square root of 21. These will reduce. I'll be left with negative 2 over the square root of 21. And then I have to rationalize this. I have to multiply by the square root of 21 over the square root of 21. And I'll get negative 2 times the square root of 21 over 21. And that would be my final answer there. And then finally, I'll shrink this as well. And there you have it. That's how I would go about doing those. And then again, 15 is going to be a little bit easier because 15, you're going to be able to recognize which point it relates to, and then you should be able to go through and start plugging in all that information. Again, I apologize for kind of the spacing on this and how it all works out, but you should be able to go through and figure that out. And it's, again, a matter of these formulas when we're looking at the unit circle specifically. All right, number 19, 19 through 43 is just asking you to find specific values. And these are all things that we're either going to know based off of the 6.2 part 1, 6.2 part 2, or 6.2 part 3 notes. The chart that I have doesn't give these because these are pi over 2, but for 19 through 28, 19 through 28 are all quadrant angles. So what I'm going to do here for number 19, sine 11 pi over 2. First thing I'm going to do is kind of figure out where 11 pi over 2 is. And here's how I go about doing this. This is 1 pi over 2. This is This is 1 pi. I apologize about that. So I start forming an angle. This is 1 pi over 2. When I get up here, that's 1 pi over 2. This is 3 pi over 2. When I get back up here, I'm at 5 pi over 2. Then I'm at 7 pi over 2. 9 pi over 2. 11 pi over 2. These work in odd numbers and they go over 2. So now I'm terminating here, and I know that I'm looking at the point 0, -1. Well, I'm on the unit circle, so my sine is equal to my y value. So in this case, this is -1, and I stop there. For the cosine of 7 pi, I'm going to go ahead and draw my coordinate plane, and then I'm going to calculate this by this is 1 pi, this is 2 pi, this is 3 pi, this is 4 pi, this is 5 pi, this is 6 pi, this is 7 pi. So that means it's terminating over here on that quadrant angle. This is the point -1, 0. I know that my cosine is equal to my x value, so this is -1. So that's how I go about doing these. I just start drawing out these angles knowing which quadrant they terminate in. On my answer key, you'll see all of these drawn out to see their terminating point. Now there are some negative angles I'm going to have to work with as well, and this makes it just slightly more confusing. Luckily for this first one, we're already working with something we know well. -3 pi over 2, I'm going to draw this out. So this is -3 pi over 2, we should know that one. This is terminating at the point 0, 1. We know that our cosine is equal to our x value. I'm being asked cosine here, so my answer here is 0. Sine of -3 pi, so I'll go through. I'll draw out my coordinate plane. I've got -1 pi, -2 pi, -3 pi, so it terminates here. I'm looking at -1, 0. My sine is equal to my y value, so my answer here is 0, and I leave it as is. So that's all I need to do for those. It does help if you draw these angles to figure out which quadrant you're ending on, and then you're paying attention to your x, y values and where they fall within your formulas. All right, 29 through 43 are asking you to perform some operations based on these things. All of these are going to end up being quadrant angles, or they're going to end up being quadrant 1 angles, so this is pretty straightforward. I've got my sine of 45 plus the cosine of 60, so what I'm going to go up, I'm going to go up to my chart here, and you have this chart in your 6.2 part 2 notes as well as your 6.2 part 3 notes, so I would pay attention to this. At 45, my sine is √2 over 2, and pi over 3, my cosine is 1/2, or 60 degrees. So I go to those two, I go down, and I look here, and I say, okay, that means I'm looking at the square root of 2 over 2 plus 1/2. And I can rewrite this as √2 plus 1 over 2, and I really can't simplify this anymore. So I'm going to leave it right there. For 33, I've got the sine of 45 times the cosine of 45. Well, we've already seen this on the previous one, that the sine of 45 degrees is √2 over 2. And you're going to start memorizing this because you're going to do it so often. So don't worry. Really quickly, you're going to start picking up some patterns, and it's going to save you time. The cosine of 45 is up here on this chart. I'm going to look at 45 degrees. And I'm going to see here, okay, where's my cosine? Well, my cosine is also going to fall at √2 over 2. That's going to be my answer there. So I'm multiplying this out. I've got √2 over 2 times √2 over 2. This is going to end up being 2 over 4 because I multiply across my numerator and I multiply across my denominator. And that simplifies down to 1/2. All right, for 39, I've got 2 times the sine over pi over 3 minus 3 times the tangent of pi over 6. So here I'm going to start off with 2 times whatever my sine of pi over 3 is. I'll go up to my chart. I'll look at pi over 3. My sine of pi over 3 is √3 over 2, so I'll write that in. I'm going to subtract 3 times the tangent of pi over 6. So I'm going to go up here. Pi over 6, I'm going to look at my tangent value, that's √3 over 3. That's going to reduce. Those 3's are going to reduce. Those 2's are going to reduce. I'm going to have the square root of 3 minus the square root of 3, and I'm going to be left with the 0. So my answer there is going to be 0. So that's just going through, making sure you're plugging in your tangent, cotangent values appropriately. A lot of them are quadrant angles. I'm drawing them out and applying what I need to apply. But again, just make sure you're paying attention to those details. You can kind of see a lot of that written on my answer key. You should be able to follow along there. All right, 67 through 72 and 81, 82. 67 through 82 is plugging this in on your calculator. And I've already gone over how to plug these in on your calculator, so I'm just going to verbally restate it. You can look back on the 6.1 part 1 notes if you really, really need a refresher on this. It's also in the 6.1 part 1 answer key. 67 through 72, 81, and 82 are all in degrees, so make sure your calculator is in degree mode. 73 through 80 are in radians, so I'm going to post a video for putting your calculator in radian mode. Make sure you're going between these degrees and between these modes. If you're trying to calculate radians in degree mode or degree in radian mode, it's not going to work out for you. It's going to be a rough time. So make sure you're going back and forth there when necessary and paying attention to your modes. And again, as a reminder, when you plug in cosecant on your calculator, you'll do 1 divided by the sine. When you do secant on your calculator, you'll do 1 divided by the cosine. And when you do cotangent on your calculator, you'll do 1 divided by the tangent. Now, 85 and 87 are going to look a lot like that last example you had on your video notes today. So again, my magnitude here is greater than 1, and then this is less than negative 1. So I'm looking at 2 values here that are off the unit circle. I'm actually looking at some angle that as it terminates, it's terminating over here, and it's going to be in quadrant 4. I know it's in quadrant 4 because my x is positive and my y is negative. I've got some point here for this angle. So now I'm going to go through and I'm going to say to myself, oh, I actually have a new triangle that I'm looking at. I have this point here, 2, -3, so that means my opposite is -3. My adjacent is 2. I'm going to have to quickly do 2 squared plus -3 squared is equal to my hypotenuse squared. I've got 4 plus 9 is equal to my hypotenuse squared. 13 is equal to my hypotenuse squared. My hypotenuse is equal to the square root of 13. So I'm going to come over here and put in the square root of 13. And now I've got this angle theta that I'm looking at. So I've got that angle theta, and I can now identify, all right, I've got this as an opposite, this as an adjacent, and that as my hypotenuse. So then I just start plugging everything where it goes. My sine is still equal to my opposite over my hypotenuse. My hypotenuse is a radical, so I'm going to have to rationalize this by multiplying by the square root of 13 over the square root of 13. I get -3 times the square root of 13 over 13, and that stops there. My cosine is going to end up being 2 over the square root of 13 because it's the adjacent over the hypotenuse, but then again I'm going to multiply to rationalize this hypotenuse out, so then I'll end up with 2 times the square root of 13 over 13. My tangent is my opposite over my adjacent. My cosecant is equal to my hypotenuse over my opposite. My secant is equal to my hypotenuse over my adjacent. And then my cotangent is equal to my adjacent over my opposite, and I leave it here. And then I go through, I start asking myself, Are my cosine and secant positive because I'm in quadrant 4? Yes, they are. Is everything else negative because I'm in quadrant 4? Yes, they are. I'm happy with these answers. I'm happy with these magnitudes. You'll do that same principle with 87, but it's obviously going to terminate in a different quadrant. And again, make sure you do not do 44 through 66. Do not do 44 through 66. If you have any questions on any of the other answers in the answer key which are confusing you, again, please email me sooner rather than later. Let's work out those issues. Thank you. Have a great night.